Okay. Let's continue our discussion about colligative properties. Let's just have a little review since we did not have any lecture class last meeting. And baka nag-pass is pass na ito. Medyo nakalimutan yung ating lesson the other week. So, again, when you say colligative properties class, these are properties of the solution. Wait lang. Wala. Again. Again, when you say colligative properties, these are properties of the solution that are dependent on the number of solutes. So we did this in the laboratory. We had our boiling point elevation class. During the experiment, diba, you had 4 beakers with distilled water, and these 4 beakers contained different amounts of solute. Actually, beaker number 1 did not really have any solute na nilagay. Okay? So, actually, theoretically, if you add more solute, there will be increase in the boiling point. I'm not just sure with the result of your experiment. So, let's see during the reporting if the theoretical colligative property, which is the increase in the boiling point, supposedly is also true in your actual experiment. So that's the first one. We did not have any experiment about this vapor pressure lowering, but this one is included in the colligative properties. So when you say vapor pressure lowering, the more you add solute, there will be decrease in the vapor pressure, and that would mean that the substance will not easily evaporate. Okay? Kasi when you say vapor pressure, it's the pressure above plus the liquid kapag ka mag-evaporate na siya. Pag mataas yung vapor pressure, it means the liquid easily volatilizes. Madali siyang maging gas. Okay? So just like our acetone or our alcohol. But if we are going to add solute in this volatile na mga substances, there will be lowering of the vapor pressure, and the consequence will be hindi na siya madaling mag-evaporate. So we are done with this last meeting. Do not forget the Raoult's law that govern the vapor pressure lowering. So this is again the formula. X being the mole fraction, and then multiplied to the vapor pressure of the solvent. I think hindi ko pa napopost yung recording, no? I'll be posting the recording this week so that you can review class our discussion for this one, the vapor pressure lowering and also the boiling point elevation. But if you have questions, you may ask me. We are done also with the freezing point depression. So actually, this is your assignment, or this is your experiment na pinagawa sa inyo sa bahay lang. So just like sa boiling point elevation, you will be preparing this time, since wala tayong beaker sa bahay, sa ano lang, sa baso lang, and then you're asked to add solute. So I think that's as in right, sodium chloride. So ang kaibahan, for boiling point, there will be increase in the boiling point, but for the freezing point, as you add more solute, so any salt yan siya, as long as it's a solute, considered a solute in the solution, there will be lowering of the freezing point. So it will take a much lower temperature before the substance freezes. Yan yung ibig sabihin ng freezing point. Bababa yung kailangan na temperature before mag-freeze yung substance kapag ka mag-add ka ng solute. So when you say, for example, water freezes at 0 degrees Celsius. Napilit. Yun na yung internet. But can you hear me? Tell me if you...
Okay na, ma'am.
Okay, sige. Again, water class freezes at 0 degrees Celsius. But if we are going to add solute in water, just like asin, table salt, we will be expecting a decrease in the freezing point. So pwedeng mag-negative na class yung temperature na kailangan before mag-freeze yung solution ng water and ang salt. Yun ang ibig sabihin ng freezing point depression. So we are done with the computation last meeting. Actually, we have started with osmotic pressure. So this is the last colligative property that we are going to discuss. So last meeting, I discussed about osmosis. Pag sinabing osmosis class, there is a movement of the solvent. So take note, ano yung mag-move? It's the solvent. So saan siya mag-move? From a region of lower concentration, just like in the illustration in the screen, you have there the original beaker, this one. On the left side, there is a division there. So the left side contains lower solute concentration compared to the right side. And osmosis class is possible for this. So when you say osmosis again, the solvent will move to the region with higher concentration. So the goal of osmosis is actually dilution. We will be diluting the part or the compartment wherein there is more solute concentration. Okay? Now when you say osmosis, osmotic pressure, it's the pressure class needed for us to stop the movement of the solvent or to simply stop the osmosis. Okay? Again, there is osmotic pressure here. Now, ang tawag dyan, di ba, boiling point elevation, freezing point depression, and vapor pressure lowering. Paano naman sa osmotic pressure class? Actually, if you add more solute, there will be increase in the osmotic pressure. Siyempre, it will require more higher pressure for us to stop the flow of the solvent. Kasi kapag marami kang solute, meaning talaga mag-trigger yun ng osmosis kasi mag-move talaga yun on a region with higher solute concentration. So, kung maraming solute, mas mataas yung tendency na magkakaroon ng osmosis. And for us to stop osmosis, kailangan natin ng mas mataas na pressure. Okay? So, that means, kapag maraming solute, there will be increase in the osmotic pressure. Now, why should we learn this one? Among all the other colligative properties in our work as medical practitioner, itong osmotic pressure yung pinaka-related sa work natin. So kasi, like for example, we inject drugs or other substances directly into our vein, and we have to consider that these substances, wait lang, internet connection is unstable. Okay, we have to make sure, class, that these substances to be injected directly to the vein will have the same osmotic pressure with our blood. Okay, or in simpler terms, the solutions to be injected directly to the vein should be isotonic with blood. When you say isotonic, it has to have the same amount of solute with our blood. Remember, our blood class is not just about the serum, the red blood cells, the white blood cells, the platelets, and all the other things that we see normally sa blood. Meron ding solute yung ating blood class. You know this very well we have our ions, our electrolytes in our blood, just like our sodium, our potassium, and all the other ions, okay? So they are considered solute. And before we're going to inject any substance, we have to make sure that the amount of the solute of this substance is the same with the blood, okay? So that we can avoid complications. Ano yung mga complications? Kagaya nito, when we are going to inject hypotonic solution, which is a solution with less concentrated solution, this will really trigger osmosis. Since you inject a lesser concentrated na solution, the water from the cells in our blood, like the red blood cells, will really go, yung tawag dyan, will really, baliktad, yung ating solution, di ba, konti lang yung kanyang solute. So kapag i-inject mo siya, mas marami yung magiging solute doon sa red blood cells natin. So example lang natin yung red blood cells. No? We have other cells in the blood. Now, kasi konti lang yung sa labas, mas marami yung sa loob, ang tendency, the water class from our hypotonic solution will enter the cell, making the cell swollen, and there will be a tendency of lysis. So magkakaroon ng hemolysis if we're going to again inject a hypotonic solution. So example of a hypotonic solution is water. We don't inject water, just water, pure water directly to the vein kasi wala siyang solute. So magkakaroon ng osmosis. Since walang solute, the outside of the cells in the blood will be less concentrated, so papasok yung tubig sa loob ng red blood cells. Now, another one, kapag hypertonic solution naman ang i-inject natin, which is a more concentrated solution, baliktad, there will still be osmosis, but this time, since maraming solute yung nasa labas ng red blood cell kasi nag-inject tayo ng hypertonic solution, the movement will be from inside to the outside, okay? From inside of the cell, the water will go out kasi maraming solute na kailangang i-dilute sa labas. So ayun na, yung mangyayari. The red blood cell will shrink and hindi din siya magfa-function normally kasi nga nag-shrink na siya. We call that class crenation or crenated red blood cells. So example of a hypertonic solution, example seawater. Yung seawater na yan, maraming asin yan. So that is considered very concentrated or a hypertonic solution. Therefore, we cannot give that directly or we cannot inject that directly to the vein. Magkakaroon ng shrinking ng ating cell. Okay? So therefore, what we're going to inject to the vein is the isotonic solution. Okay? Iso means the same or equal. Meaning equal yung amount ng solute ng cells natin in the blood and also the blood itself, the serum. Equal lang siya. Equal lang yung solution na yan. Ano example ng ating isotonic solution? That's 0.9%. Take note, 0.9% sodium chloride solution. Yan yung ating isotonic. Or we call that normal saline solution. Let me write that sa screen, normal saline solution. Okay? Or kung ano ito, di ba yung mga na-admit sa hospital, nilalagyan ng fluid replacement therapy, not all of that is called dextrose. It is really called dextrose if it is really dextrose yung binigay sa iyo. Pero most of the time kasi, especially like example, dehydrated yung patient, minsan nabibigay sila, ito yung binibigay nila. The PNSS or the plain normal saline solution. Yan yung isotonic natin with blood. Okay? Questions? May nag-party-party dito sa Pikas. Sa kaya na. Ako sa Pharma Lab, so tapad jud sa GFI karon. Pag na dyan ng party-party. So ba sila music? You have questions? Wala. Sure na. So kung wala, let's move on. Let's discuss now the problem solving involved in osmotic pressure. So kung sa vapor pressure lowering, we have the Raoult's law. This time naman for the osmosis, we have the Van Hoff. Oh, okay. Ang memo sa school, we have our class today. But yung mga Islam is actually exempted. Kasi I don't know, I'm not really sure how, but if you have like activities in your, there, inside yung activities, you will now be exempted sa class. So it's okay. Pero the rest, na hindi Islam, you are not exempted. Okay. Tanan. Tomorrow pa ang tanan. Tanan ta, walay klase tomorrow. Kita tanan actually na shock sa mga pangyayari sa world. Basta paspas kay kung nakaligo. Kay I need to have my face-to-face class ngayon. Kasi ano na, week 4 na tayo, week 5 na next week. Pag hindi ako nag face-to-face sa section C today, tas walang klase tomorrow, nga silang tanan sa exam. Mas kay ko nakaligo. Actually, ako'y pamahaw eh. Gosh. Shock ang mga pangyayari sa world. Okay, sige, let's discuss Van Hoff. This one governs osmosis. And our formula for the Van Hoff, okay, is pi equals MRT. Okay? Again, our formula for the osmotic pressure is pi is equal to MRT. Yung pi dyan, it's the osmotic pressure. So we are going to compute for that. And then capital letter M is molarity. You cannot get away with the computation of molarity and normality, both in the lecture and in the laboratory class. And then R is a gas constant. So take note of the word constant. It's constant. I'll be giving you the value for this gas constant. And T is temperature. Wait, where's my pen? Dala na ko tanan among balay diri sa eskwelahan. Mga gamit. Oh my gosh. Okay, so what is our gas constant? This is 0.08205 liter per ATM mole K. Okay, again, this is our gas constant. 0.08205 liter ATM, liter times ATM yun siya actually. Liter times ATM, that's atmospheric pressure, over mole times K. K class there is Kelvin. Yan yung ibig sabihin ng K dyan. Kasi for the temperature sa Van Hoff, you have to convert first the temperature to Kelvin. Do not forget that. The temperature should be in Kelvin. If it is in Fahrenheit or in Celsius, you really have to convert. Okay, convert everything to Kelvin before proceeding in the computation of the osmotic pressure. You have to memorize this gas constant, ha? 0.08205 liter ATM per mole K. Okay, now let's start. We have here problem number 1. What is the osmotic pressure in ATM of a 0.30 molar solution of glucose in water that is used for intravenous infusion at body temperature, which is 37 degrees Celsius. Okay? So ang ating formula again is pi equals MRT. Pi is the osmotic pressure. M here is the molarity, meaning the concentration of the solution. R is the gas constant, that's 0.08205 liter ATM per mole K. And T is the temperature. It should be in Kelvin. So what is asked in the problem is the osmotic pressure in ATM. ATM dapat yung kanyang unit, atmospheric pressure. Now for the molarity is already given. That's 0.30 molar. That's the concentration of the solution, which is glucose in water. Okay? Wait lang, internet connection is unstable. By the way, class, glucose is our physiological sugar, right? Physiological sugar. So this is our sugar in the body or sugar in the blood. Other name for glucose is dextrose. Okay, so if like you are admitted in the hospital and you are given dextrose, it means you are given class with glucose, which is our physiological sugar. So this one is being prepared, dextrose or glucose in water to be injected intravenously, okay? Or to be infused intravenously. So body temperature, this is 37 degrees Celsius. So if we are going to substitute all the given, you have the molarity 0.30. Let me just use mole per liter. Remember, capital letter M is equivalent to mole per liter. I need to use this one so that I can properly cancel the units. Now, R is 0.08205 liter ATM over mole. Okay. Okay, that's the R or the gas constant. And then the temperature. So for the temperature, we need to convert this first to Kelvin. What is our formula in computing the Kelvin? Can you still remember that?
Celsius plus 273 Kelvin po.
Okay. Sige, Celsius plus 273. Let's just use 273. Or actually, pwede din namang 273.15. Let's just use 273. Okay, again, let's just use 273. Let's simplify things. Okay, so this is 37 plus 273. Ilan na? Siyempre, mag-calculate ta. May trust issues ka sa ito ang mental math. 37 plus 273 is 310 Kelvin. Let me check. Yeah, that's 310. So this is 310 Kelvin here. Before we'll multiply everything, let's try to cancel the units. You have mole sa baba, so you can cancel that. Liters also. So may liters tayo sa taas. And then Kelvin. So take note, ano yung maiiwan na unit? It's ATM. So in this case, tama yung magiging unit natin. So 0.30 times 0.08205 times 310, 2 decimal places. Yes, it's 7. The osmotic pressure is 7.63 atm. This is the osmotic pressure of the prepared glucose solution to be infused intravenously at a body temperature of 37 degrees Celsius. Okay? I hope nasundan yan siya. This is not really a very complicated na problem solving as long as you memorize already this one, the gas constant, and you know how to convert Celsius to Kelvin. Ito na lang yung kapag ka hindi given kasi yung molarity, you have to compute for molarity first. Pero I hope gikag Chem101 naga-molarity na ta hangtod karon molarity gihapon. I hope you have mastered already how to compute the molarity. Okay, questions for problem number 1. Anything that you would like to clarify? Wala. Okay, sige. So let's try problem number 2. A 0.5 liter sample of an aqueous solution containing 10 grams of hemoglobin has an osmotic pressure of 5.9 torr at 22 degrees Celsius. What is the molar mass of hemoglobin? This one is a bit complicated. Okay, na-disconnect. Baliktad kasi ito, class. The osmotic pressure is actually given in the problem. That's 5.9 torr. And what is asked here is the molar mass. If I can remember correctly, may exempted sa quiz ko, no? Last meeting, meron yun, di ba? Tama ba? Or dili? Dili tama. Wala exempted. We will have a quiz next meeting class next week. About this one. That will be a long quiz na. Ay, wala ko pa na-announce na exempted. Ay, tama. Pinasend ko nga pala yun sa sa Schoology. Okay, okay. Kasi, ano pala yun, no, yung solution ninyo. Okay, I'll check that. And then, before Monday, I'll be announcing sino yung exempted. For the meantime, dagdagan natin yung list ng exempted natin. You try to solve this one. And yung makakakuha ng tamang sagot will be added to the list of the exempted sa quiz next meeting. Isang quiz lang ha, kasi hahatiin ko yung quiz next meeting. So, you will be exempted to the first quiz. You try. And then I think last meeting also, I have given you the conversion of torr and APM. You try to review your notes. I'll give you time to answer this. Sige, go. Okay, let's answer this. Again, what we are looking here is the molar mass of the hemoglobin. And all the other things are actually given. So you have to start with the original formula of osmotic pressure. Pi is equal to MRT. pi is given in the problem, that is 5.9 torr. You have to convert that since our unit for the R is 0.082205 liter ATM. So, hindi ka makaka-cancel ng unit kung hindi sila magkapareho. Okay? So, this is 5.9 torr. Ano yung sabi ko last time, yung conversion, 1 ATM, ano binigay ko sa inyo? Is equal to 760 torr. Okay? Binigay ko ito sa inyo last time. So, diretso ko na lang pala ito. Again, isang ATM is equal to 760 torr. Okay? So you cancel this to get the ATM. And hanggang sa 8:50 AM lang na nag-send yung tipingan ko. 5.9 divided by 760 is 7.763157895 times 10 raised to the power of negative 3 ATM. So yan yung gagamitin ko here. Again, do not forget, I'm not fond of rounding off during the process. Okay? Hindi ako nagra-round off during the process. I only do the rounding off sa final answer. 315 sa GFI. 7895 times 10 raised to the power of negative 3 ATM. Molarity is not given in the problem. Okay? Wait lang. And then, bakit ayaw niya? Wait lang. Kaya dili siya mag... Yeah, same lang sila value sa torr. You'll get the same answer. Right? Times the R, 0.08205 liter per ATM, and then mole K. Okay? This is our gas constant times the temperature. What's the temperature? It's 22 degrees Celsius, so let's convert first. This is our formula. 22 plus 273. Ilaman na. 295. So this is 295 Kelvin. Wait lang, make two space. Okay, so let's proceed. Let's have 7.73157895 times 10 raised to the power of negative 3 ATM equals, let's multiply this one, 295 times 0.08205, that's M times 24.2047.5. Let's try to cancel the units here na maka-cancel. So, ang makancel dito is ang Kelvin. So, we will be left with liter ATM per mole. So, divide both sides with the 24.20475 liter ATM per mole. Liter ATM per mole. So, cancel the ATM. You have the molarity here. 7.76315 7895 divided by hindi kasi nulat yung 24.20475. Okay, so this is 0.320 728,695. Yung unit niya, class, since si mole, liter per mole, kinancel kasi natin si ATM, nasa baba siya. We will be getting the reciprocal. Babalik na rin natin, di ba, pag nasa baba yung unit na maiiwan. So this will become moles per liter. Therefore, this is the molarity. Remember, moles per liter is equivalent to capital letter M. Okay? So pag meron ka ng molarity, you may proceed with the computation. So di ba yung ating molarity is equal to moles per liter. Ito yung ating formula talaga. Now, meron tayong molarity na 0.32728,695 mole per liter times, not times, equal. Nawala. Wait lang. Ulitin ako. I hope you copied that already. Anyway, this is being recorded. So, na-record na yun sa video. Dito na ako mag-start sa molarity class. Wala. Kalagot. Okay. Sige, let's continue. 0.320. Tapos kaya itong dissolve. Tapos makalit siya kawala. 0.32728,695. Wala makakapi. Sige lang na. Naka-record man siya. Okay. Pag-review sa recording so that you can copy the computation. Moles per liter equals. Hahanapin natin ngayon class yung moles. Kasi yung liter ng solution given naman. So that's 0.500 liter. So cross multiply, you will have moles is equal to, i-multiply natin yan siya, 0.320728,695 times 0.5. That's 0.160364347. Okay? And then, di ba, meron pa tayong isang formula, moles is equal to weight of the substance divided by its molar mass. So, to get the molar mass, you can use this formula. Meron tayong moles dyan, 0.160364347 mole equals, given yung weight ng ating substance, that's 10 grams. Divided by the molar mass. So cross multiply, you will have, wala na ko space, 0.160364347 mole times M equals, ang may iwan sa kabila, 10 grams. So divide both sides with this one. Makakataas. Shortcut ko ha. Shortcut ko yan. Kaya di na siya makasya. Ano na lang. It's 0.160364347 moles ha, yung i-divide ko dito sa 10 grams. So the correct answer is 62.36. Take note of the unit, grams per mole. Let me review lang ha, baka may na-miss ako sa computation. Wait lang, review ko lang. Paano nag-come up? Parang taas dyan kayo to ba? Ayan na. Ulito na ko ha. Sa calcul na lang ako mag-ulit. Let me just check kung tama ang process. Divided by 0.08. 0.08205 times 22 plus 273, 295. It's 320 times the 0.5, that's 1.6. And then 10 divided by 1. Bali din. 62. Ano nangyari doon kanina? 1.60. Nakalimutan ko yung... Wait, ulitin ko. May mali ako sa process na ginawa ko. .0825 times 295. 3.20 times 0. Meron pala yun siyang ano. Nakalimutan ko yung scientific notation. Okay. Nakalimutan ko may scientific notation pala ito. Wait lang. Ulitin natin siya. May scientific notation pala ito. This is the molarity is equal to moles per liter. Hindi ko kinopya yung scientific notation yan. 327 to 86956 times 10 raised to the power of negative 4 pala ito. Pakulbaan mo. Okay, nakalimutan ko yung times 10 raised to the power. Ano namang gadili mag-antipara, no? Okay, and then we'll compute for the moles. The liter of the solution is 0.5 liters. Cross multiply. Moles is equal to times 0.5. This is 1.603,643,78 times 10 raised to the power of negative 4 moles kasi makakancel yung liter. Pag meron ka ng moles, you can now proceed with the computation weight over the molar mass. So ang mole is 1.6 1.6364378 times 10 raised to the power of negative 4 moles equals, the weight is 10 grams, and then this is molar mass. Cross multiply, you will have the 1.603,643,78 times 10 raised to the power of negative 4 moles times the molar mass. May iwan sa kabila is 10 grams. So divide both sides with this one. Shortcut ko na kasi ang haba. 1.6 times 10 raised to the power of negative 4 grams. So, molar mass is 10 grams divided by 1.603,643,678. That's 62,358. Take note of the unit, grams per mole. So ito yung sagot natin for the molar mass of our hemoglobin. So let's check. Sabi ko kanina hanggang 850 yung tatanggapin ko na answer, right? Back read muna ako. 62,358. Ano nga yun mag-start? 62. Bakit negative 4? 62,358. Sige, Juliana, kindly send sa Schoology your solution for this. How did you get the 62,358 grams per mole? Mag-PM lang ako sa mga exempted, ha? And then, Baligasa also, kindly send to me your computation for this. Escalante also. Ngayon na ha, ngayon na. Ayun na lahat. Wala na. Ayan na yun. Ayan. So, ayun na yun lahat. Tatlo lang yun, di ba? Baligasa, Mulano, and Escalante. 62,358 grams per mole. Please send your solution. I want to see your solution before I'll confirm if you are exempted sa quiz next meeting or not. Okay? So ano yung ginawa natin, class? Paki-review yung ginawa ko kanina ha. Kasi medyo mahaba yun. Again, our original formula is pi is equal to MRT. Now, pi is already given. That's 5.9 torr. But you have to convert first the 5.9 torr to ATM. So, do not forget our conversion factor. Sa isang ATM class, meron kang 760 torr. So, convert this first before you can proceed with the computation. You're going to look for the molarity. The gas constant is still the same, 0.089 liter ATM per mole K. And then, the temperature is also given, 22 degrees Celsius. You just have to convert this into Kelvin. So, for you to get the molarity. Ito yung tanong kanina, paano nakuha itong 0.320786956. Ay, sorry. Bakit talaga ng 9 dyan? 0.08205. Okay? And then, pag nakuha mo na yung molarity, you can now compute for the moles. So, molarity lang siya times the liter of solution. That is 0.5 liters. Kaya natin nakuha itong 1.6 times 10 raised to the power of -4. Pag meron ka ng moles, you may proceed na sa molar mass na talaga. Ito yung formula natin ha. Medyo mahaba itong computation na ito. Moles is equal to weight over the molar mass. Okay? So, the weight is given, that's 10 grams of hemoglobin. And then yung moles na compute na siya from the previous na ginawa natin. So, i-cross multiply mo lang muna before mo i-divide. Okay? So, kaya naging 10 grams divided by the moles. So, 10 divided by 1.6 times 10 raised to the power of -4. Kaya siya naging 62,358 grams per mole. So, medyo mahaba. Maraming numbers nakaka-confuse. Any question regarding this one? Pag hindi ko na-post yung recording, kindly remind me ha, kay busy kayo ang live. Sa'yo makalimut pa. Okay? So, ang step nito, pag molar mass ang hinahanap, first compute for the molarity. That's the first step using this formula. Second, compute for the moles using the formula for molarity. Molarity is equal to moles per liter. Pag meron ka ng moles, compute now for the molar mass. Ito naman yung gagamitin na formula. Moles is equal to weight over the molar mass. Okay? Walang questions? So let's have problem number 3. For problem number 3, what is the osmotic pressure of a solution with 5 grams glucose dissolved in 2 liters of pure water to be injected through IV infusion at body temperature? Our body temperature is 37 degrees Celsius. Sige, you try. Let's add some more people na ma-exempt natin sa quiz next meeting. Pero I'll just give you time for this ha. Hindi yung matagal masyado. Pero again, please try to read and understand the problem and send me your answers via DM. I-direct message lang. Recording. Okay, so what is the osmotic pressure daw? Osmotic pressure ang hinahanap ha, of a solution with 5 grams glucose dissolved in 2 liters of pure water to be injected through IV infusion at body temperature. So, we'll go back to our main formula. Pi is equal to MRT. We are looking for the pi class, remember? But for the molarity, syempre wala. Later na natin yan siya ilalagay dyan. Yung ating R, 0.0825. 0.08205 liter per ATM mole K times our temperature. Again, that's 37 degrees Celsius. Let's just convert. 37 plus 273 is 310 Kelvin. Okay, let's check. Yeah, it's 310 Kelvin. Now, our problem is the molarity since hindi siya given dyan sa problem natin. Take note, plus molarity is equal to moles per liter. Walang moles na nakalagay pero the liter of the solution meron 2 liters. Hanapin muna natin yung moles using this formula, weight of the substance divided by its molar mass. So the weight of the substance is 5 grams. And for the molar mass, glucose, I hope ni-research nyo na lang siya.
180, ma'am.
180. Pero ano yung chemical formula ng glucose? C6?
C6H12O6.
Okay, C6H12O6. This is CHO. 6, 12, and 6 multiply sa kanilang atomic weights. We have 12, 1, and 16. So 6 times 12 is 72. This is 12. And 6 times 16 is 96. So again, 72 plus 12 plus 96 is 180 grams per mole. So yan yung gagamitin natin here. 180 grams per mole. Cancel the grams. 5 divided by 180 is 0.0277 grams. Yeah. Bakit merong grams? This is moles. Okay? So, meron na tayong moles. Ayan. And then, ilalagay natin yan dito. To get the molarity. So, 0.027777 mole divided by 2 liters is 0.0138. This is continuous na 8 moles per liter. So, ayan, meron na tayong molarity. Hindi pala siya kakasya dito sa aking nilagay na space. Let's delete this first. Hindi siya kakasya. So, molarity is 0.013888 moles per liter times the gas constant 0.08205 moles liter ATM. Oops. Yari. Wait. Wala. Bakit? Wait, baka nag-block akong screen. Ayan. Balik na siya. Again. Liter ATM per mole. Okay, times our temperature a while ago. 310 Kelvin. So let's cancel the units. We have mole, liter, and then Kelvin. Therefore, our osmotic pressure here, 0.0138888 times 0.08205 times 310. 2 decimal point, we have 0.35. Oh, Kelvin pa na ako gibot, ha? This is APM. Okay? 0.35. Okay, tama. 0.35 ATM. Let me check. Backread. 920 ang sabi ko, di ba? 920. So, hanggang dun lang sa nag-send ng 920. Take a picture na kung nakaabot mo sa 920 and then pakisend sa inbox ng School UG. Pag wala yan sa inbox, hindi din kayo ma-exempt. Juliana, no. Sheila Cantones. And yes, Juliana. Molano. Villanueva. Ano naman na question mark? Guanzon. Dasilio. Escalante. And Olarte. And GAPA also. GAPA. Again, kindly send your solutions sa aking inbox sa School UG. Okay? Pag hindi ako nag-reply, class, it means hindi ka kasali sa exempted. Okay, magre-reply ako doon. Pag hindi niyo yan na-send, hindi yan kasali. Anyway, this is being recorded. Yung mga hindi natawag, hindi magsasend ha. Pag may nag-send na natawag, na hindi natawag, madoble yung quiz next meeting. Okay, so again, in this problem, we are computing for the osmotic pressure of the solution of the glucose. So molarity is not given. That is the reason why we started here on the right side. We computed first for the moles, since moles is not given, but 5 grams, the amount in grams is given. So 5 grams divided by its atomic weight, that's 180 grams per mole. We get the moles here, and then we use the moles to compute for the molarity. So by dividing it to the liter of solution. So this one, 2 liters yung ating solution dito. Na pag nakuha mo na yung molarity, you can proceed with the computation. You have the molarity now and the gas constant, and saan galing ang 310 Kelvin? It's the body temperature, which is 37 degrees Celsius converted into Kelvin. And then i-multiply lang siya lahat, cancel the units. That's how we got the 0.35 ATM. Okay? Do you have questions or clarifications? This is the last slide for our colligative properties. Okay, gusto kayong itanong or i-clarify? Wala. So sige, i-summarize natin yung ating colligative properties. Ulit-ulitin ko talaga ha, pag sinabing colligative properties, these are the properties of the solution that are dependent to the amount of solute. So kung magbabago yung amount ng solute, magbabago tong properties na ito. 4 lang class yung colligative properties natin. Number 1, vapor pressure lowering. If you add solute to a solution, it will lower down the vapor pressure. And what's the consequence? The solution will not easily volatilize. Hindi siya agad magiging gas. So just like you have acetone, if meron kang pure acetone, madali yun siya mag-volatilize. Pero if you add solute to the acetone, any solute, magbabago yung kanyang vapor pressure and hindi na siya, mababawasan na yung kanyang volatility. Okay? And then we have boiling point elevation. If you add more solute to a solution, it will increase the boiling point. So it will take higher temperature before the solution to boil. And then we have the freezing point depression. It's the vice versa of the boiling point kasi when you add class solute to a solution, the freezing point will be decreased. Okay? So bababa yung kailangan na temperature before mag-freeze ang isang substance. So if we compare that, diba, sabi ko kanina, water freezes at 0 degrees Celsius. Pero kapag ka mag-a-add ka ng solute doon sa tubig mo, mabababa yung kanyang freezing point, pwede na siyang mag-negative. Okay? Mag-negative na siya before siya mag-freeze. And lastly, you have the osmotic pressure. Take note that the addition of the solute will increase the osmotic pressure. The osmotic pressure is the pressure required for us to stop osmosis. Osmosis is the movement of water or any solvent from a region of lower to higher solute concentration. Remember our goal? The goal of osmosis is to dilute. Kapag ka masyadong maraming solute na sa isang compartment, mag-move yung water para i-dilute yung compartment na yon. Okay? And again, in order for us to stop osmosis, we need the osmotic pressure. So yun yung kinompute natin a while ago. Osmotic pressure is equal to MRT. M is the molarity. R is the gas constant. That's 0.08205 liter ATM per mole K. And then, i-multiply natin sila sa temperature. Do not forget na yung temperature kailangan munang i-convert into Kelvin. Okay? Hindi ka din makakapag-cancel ng unit kung hindi sila magkapareho. Kasi yung ating gas constant is naka-Kelvin. So, kailangan mo din i-convert yung temperature kung Celsius ang binigay. Now, kapag ka sa problem class, ang binigay is just body temperature, hindi binigay yung exact one. Body temperature class is 37 degrees Celsius. Okay? You have questions about our colligative properties? We will have a quiz for this next meeting. Ihahati ko class yung quiz. I'll separate the objective na part and I'll separate the problem solving. So yung mga nag-send sa akin, sabi ko exempted. Doon lang ha sa first part kayo exempted. If ever, ma-check ko na yung inyong solution. So make sure to send your solutions now na para ma-check ko yan.